Hello, welcome to the first video in a new series we're going to cover, which uses the data in our vast facts and dimensions database, which has all sorts of data on all kinds of open data, child obesity, coronavirus, dementia, disability data, digital maturity, and so on and so on and so on. And we're adding more and more every week. The aim to have all open data in one single database. What I'm going to do in this video is show how to use this brilliant new tool in Snowflake, Cortex Analyst, to analyze the vast data in our database. And in this first one, I'm actually going to show you how to query our database to find out what data we have in our database. So to get started, you'll want a Snowflake account. So you'll need to go to signup.snowflake.com. Fill all that in and you can get a free 30-day trial to Snowflake. And then when you get there, go to the marketplace or follow that link from our website. Just look for Facts and Dimensions All Data Trial and you'll find this link and you can get a free 30-day trial to our data. And so you'll have Snowflake and our data both free 30-day for a trial. So I've already done that, of course. Now, when you get into Snowflake, click AI and ML and then click on Cortex Analyst Try. Then create new semantic view. Then give your semantic view a name. I'm going to call it search tool because that's what I'm going to do. I already made one earlier. I'll just call it search tool 2. Call it search tool 2. Then I'm going to pick the table or tables I'm interested in building my model on top of. So in this case, I'm just going to pick one table, which is this new table we added recently called release details dot where is it? Here it is, release details dot FAD search data. This table contains a copy of every single value from every single column, from every single table, from the thousands of tables across our entire database. And the reason we've done that is to make it easier to find what tables contain data on any particular word or bunch of words or phrases. And the reason we did that is because before then, you could only really search on the table name or description, which you just can't fit enough information in the table name or description, really, especially for things like public health, which have a wide variety of metrics in the table. Right, so we're not going to do the search, the Cortex search, because although it's very good, it takes about an hour to set up. So we'll leave that, and the table's small enough to run really fast anyway. Create and save. Right, I can actually start using it immediately. So I could start by clicking this button where it will have a look at the data contents and have a go at describing it. You can have a quick read of this. It does pretty well explain the table in there just based on the contents, but I'm going to help it along by giving it a bit more info. And as I think I might have said, Snowflake are going to allow us data providers to add these semantic views, such as the one I'm making here, into shares that we provide to our customers. So we'll be making semantic views for you to use ready-made, but even then, you'll still want to follow this video to learn how to make your own. So first of all, we need to go into each of the dimensions and add some synonyms to help the AI tool understand this table. So as I say, this will be something we'll be doing for you, but when you're doing your own, this is what you'll do. Let's give it a description. Well, this one's column name, so name of the column in the table in the database being searched. Synonyms, column, field, that'll probably do. Then I'll want to give a synonym to column value. So this is the values. This is a list of every value, every column value in every column of every table of every schema in the whole database. The AI tool uses what I'm writing here to help it answer questions, by the way, so it does matter what you put in. Synonym, column value, metric, measure, code value. No, I've already put value. Well, value, the word value on its own. That'll do. We can always change it. That'll do for now. I've got a time dimension we added in. That's the date that the last time that the column value had appeared. So let's say that. Date, the last time the value in column value appeared in the table. Synonyms: date, latest date, latest, most recent. That'll do. Another fact one we've got here is row count. So that's the number of times that the value in the column has ever appeared. So let's call that frequency count, number of rows, number of times. Let's save that. We've also got view name and view schema, but I think it's better to have one what do you call this, dimension, which is the schema dot view name, right? So I'm actually going to remove these two, view name, and I'm removing view schema, and I'm going to add a new dimension where I combine them, and put a dot in the middle, so it's similar to how we're used to seeing it when programming. Probably should put speech marks around that too, in fact. No, let's leave that as it is. That'll do. Right, dimension name, view schema. Oh, we need the underscores. View schema and name. It's a varchar. What would we describe it as? View schema and name. Synonyms: view, table. I think that'll do. Now, in later videos, I'll start adding multiple tables and teaching it how to relate the tables. I've got other metadata that can help you know how to do that. That will do for that. So, and we can also do custom instructions, but I'll show you that in a future video as well. But let's just try it out now. So let's query. Let's get rid of that. Now it says there's an unknown function concate. Oh, I misspelled that. It's concat. Save that. Okay, now it's ready to go. Right, so now I can start querying it. Do you? No. Let's say, what tables do you have on stroke? It's great. Every time I've actually redone this video that I'm trying to do without mistakes, I keep changing the way I word it, and it still works. So it's pretty good. So it's made the actual SQL statement, so I can verify if I think it's doing what it should be doing. It's selecting a distinct list of the view schema name from the FAD search data. FAD search data being this CTE, where column value I like, so case insensitive, stroke, and that is right. This is all the tables that have a value somewhere in the table with the word stroke. So that works. We can actually just try it out. So let's copy the physical query. We'll put it in here. Try that out. So this is a list of all of those that have the word stroke, and it's a CTE selecting everything from the facts and dimensions, all data, release details, FAD search data, which, as I said, is the table that lists every value that has appeared in every column of every table. And it's giving us the list of tables where the word stroke has appeared somewhere in one of those column values. So let's just check. So this one, it says it's in there. Let's query in a more natural way, or sort of a way I'm familiar with. So we should find that this table comes up. So if I just focus on that actually. Right, so that should come up with 1. And it has. So in this table, there are 9,278 rows with this specific value: stroke, quaff, prevalence, all ages. So that's good. So that's there. Now, let's get a bit more detailed. Let's imagine I wanted to find all the tables that have the word stroke in it and also have the word Manchester in it. Now, I'll tell you how to do it wrong. This is from my earlier experience earlier when I was playing with it yesterday. What tables have data on stroke and Manchester? Now, the problem with this, assuming it does the same as it did yesterday, is it'll try and look for all those tables that have values where the value has the word stroke and Manchester in the individual value, which will probably be none. But actually, no, there's a few. Surprisingly, there is actually a few. Okay, let's have a look. There's fewer, but there is some. All right, let's do the physical, copy that physical query, put it into here. So these ones actually do have the word stroke and Manchester. If we just have a look at everything in that table, where column value like stroke and column value like Manchester, wasn't actually expecting any, but clearly there are some values in our database where there's a sentence, I guess, with the word. Okay, yeah, so there are, of course, yeah, there are some tables like these academic ones which have very long sentences. Yes. Like here, for example. Yeah, I mean, I'm not going to read all that, but obviously the word stroke and Manchester is in there somewhere. What I'm actually interested in is the tables that have the words stroke and Manchester somewhere in the table. So to do that, let's be a bit more specific. Create a list of tables with the word stroke and another list with the word Manchester, and then return a list of tables that are in both. I'm not sure if that will work because I haven't tried it exactly worded like that before. Let's see how it goes. Create 2 lists of tables, one with tables containing the word stroke and the other with tables containing the word Manchester, and return the list of tables that are common to both lists. That's it. Yeah, that is it. Do you know what? I think this is, well, I guess Snowflake are sort of making their models better in the background as well, because this didn't work very well the first time I tried it when it just came out. Yeah, so this has done what I thought it would do. It's made a CTE for the whole table, and a stroke tables one, so it's selecting from that CTE, but only the ones where the column value has the word stroke in it, and this one, which has the word Manchester in it, and then it's selecting from the first CTE and intersecting with the second CTE, thereby only returning the values that are in both. So that is good. That works. Anyway, I think that'll do for this video. Obviously, we can get into much more interesting stuff. So have fun. Thanks.